completely done this, so you probably won't be watching, but those of you who need to maybe check a couple of answers here and there, it's available. All right, so constant proportionality. If we're asking for the constant proportionality, you can pick any point here. 2 and 12, 3 and 18, 4 and 24, 5 and 30. I'm just going to pick the easiest, which is the first one. So k equals y over x, which is 12 over 2, and my constant proportionality is 6. So therefore, my equation equals y equals 6x. Pretty simple, right? To check if a point, so if it's on the line, so we have an equation here. If we were to graph it, right? Let's call this x and y. It looks like this, right? And we have 2 and, so this is 2 and 12, 3 and 18, 4 and 24, 5 and 30, etc., etc., etc. So they're asking, what the point 963, if we were to extend the line, do you think 9 and 63 is on the line? So one way to do that is to substitute. So I'm going to take an example here. I'm going to use 4 and 24, the point 4 and 24. Let's use that to see. I mean, we already know it's on the line, but we're going to use the equation to just confirm that. So here's my equation of the line, which is y equals 6x. I'm going to replace the y and the x with a value 4 and 24. So y is 24. Let me just write y and x here. 24 equals 6, and the value here is 4. X equals 4, so replace that. And you know that 24 equals 24. You know it's equal to each other, therefore that point is on the line. That coordinate plane satisfies and makes the equation true. Now, the point 9 and 63 does, if this point is on the line, we're going to get that one side is equal to the other side. But if not, they're not going to be equal to each other. So let's use the equation of the line, which is y equals 6x. Substitute, we get 63 equals 6 times 9, and 63 and 6 times 9 is 54. So you can tell that this point does not satisfy the equation, therefore the equation is not true, and therefore the point 963 is not on the line. Okay, simple. This one. Okay, so we go back to units. We have 124 cookies. God, hopefully I'm doing the right one. 2 and 3/5 pounds of chocolate. So with 2 and 3/5 pounds of chocolate, we can make 124 cookies. They're asking us, with 1 pound of chocolate, how many cookies can I make? So this is that, what do you call, the unit rate, right? So the one thing I'd like to do, and I know you have calculators, but if you didn't, 2 and 3/5, okay, I'm going to write it as 13 over 5. So I'm going to show you how we get the 13 over 5 to become 1 pound. So 13 over 5, I'm going to multiply by the reciprocal, which is 5 over 13. And the top is also 5 over 13, right? We multiply by 5 over 13. And you can use your calculator. 124 times 5 and divided by 13. 124 times 5 divided by 13 gives you 47. And we're going to round this to the nearest hundredth. So we get 47.69 cookies. So with 1 pound of chocolate, we could make 47.69 cookies. That's your unit rate. Okay. Next one, which graph shows a proportional relationship? Well, as long as it goes through our origin, right? It crosses the y-axis at 0. It's a straight line. I forgot to say that. So this one, not proportional. This one, yes, it's proportional. This one is, yes, it's proportional. And this one, not proportional. Explain how you decided whether or not graph D. Well, graph D, the line does not cross the y-axis at 0. Okay, which would have been this point right here. Okay, it's a straight line, but not proportional. 5. Okay, so the reams of paper, constant proportionality. Okay, so then you want the equation of the line. So if I just imagine this for a second, 8 reams of paper, and I paid $43.92. So that would be my dependent, independent. So this is my x. Right, so here's a point. And 7 would have cost this much, 6 would have cost this much, and so forth, and so forth, and so forth. So we want the equation of the line as well here, right? So let me write that as a fraction. 8 reams. So if this is my y value and this is my x, right, I can just divide 4392 divided by 8. I have no idea what that is. That gives me 549. So, okay, the constant proportionality is 49, which means that when it hits 1 here, this would have been 5.49 because that's the unit rate. Right? So the equation of this line is y equals 5.49x, right? Because nothing, that's it. Okay. 5, the relationship between the length of a collateral triangle. So an equilateral triangle has sides, all sides measuring the same. So if this is 1, this is 1, this is 1, okay? And the perimeter of the triangle y can be represented on a coordinate plane with a straight line. So let's try to understand that. So x is the length. Y is the perimeter. Right? So there's a certain relationship that's happening here. So if the length of the triangle is 1, it means that all the sides are 1, which makes my perimeter 3. If I change my triangle and tell you that all the sides measure 2, my perimeter will be 6. If all the sides are 3, my perimeter will be 9. So again, here, if my length is 4, the perimeter will be 12. So I think you see a relationship happening here. So I can take any of these points, right? And again, find the constant proportionality. And the constant proportionality is 3 over 1, which is just 3. Which gives me my equation, which is y equals 3x. And you already knew that because I'm pretty sure you saw this. Times 3, times 3, times 3, times 3. Right? So we have a graph, and I'm going to sort of write something like this. Y equals 3x. When x is 1, this was 3, right? When x is 2, it was 6, and so forth and so forth. So that's what my graph looks like. So now they're asking us if these points are on the line. You can clearly tell that 1, 4, it wouldn't be on this line. Right? 1, 4 would be over here like that. Well, but I'd much rather you not prove it that way, but instead use the equation of the line. So the equation of the line is y equals 3x. Now, if 1, 4 resides on top of this line, then the left side is going to equal our right side. So let's substitute. So y is 4 equals 3 times x, which in this case is 1, and you can clearly see that they're not equal to each other. So this point is not on the line. Now, I already created a table, so you already know that 4 and 12 is on the line. But again, I just want you to get used to this. So when y is 12, we multiply 3 times x, which in this case is 4, and this is equal to each other. That's okay. We already knew that. And 4, 12, which is somewhere over here, is on the line. 10, 30. Same thing. It's 10, 30. I'll replace y with 30. And I'm going to replace x with 10. And you see that 30 equals 30. So therefore, that point is also. So 10, 30, the point 10, 30. Let me stretch that line out. The point 10, 30 would also be on the line. Okay? Find the equation of the line. So this one, it's not proportional, but it doesn't stop us from finding the equation of the line. Okay, so our line is going to be where b is the y-intercept. Now, I'm going to add some numbers here. So that's 2, that's 1, that's 3, that's 5, that's 7. That seems to stop me from doing that. So that's 0 and 8. So halfway between 0 and 8 would be 4. So 0, 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. All right, so that helps me a little bit. So this is saying that B, my y-intercept, is 20. So this line crosses the y-axis at 20, where y equals 20. Now, I still need to find, what do you call it, the slope, m. Right, and to find the slope, we need 2 points, so you can pick any 2 points you want. Let's pick, I don't know, let's pick 0. Oh, can we pick 0 and 20? Yeah, why don't we pick 0 and 20? And I'm going to pick another one that I can see, 2 and 24. So here are the 2 points I want to use. I'll call this x1, y1. I'll call this x2, y2. And m is y2 minus y1, which is 24 minus 20 over 2 minus 0. That's going to go 4 over 2, and m equals 2. So my slope is 2. And again, y equals 2x plus 20. We're done. If by any chance you didn't have the y-intercept, well, we do. We could have used this particular setup. So let's pretend we didn't have the y-intercept. We didn't know it crossed the y at 20. I could have used any other the other points. Let's say this point right here, which looks to me like 8 and 36. I could use this point or any other point. Just plug it back in here. So this is the x and y. So let's plug that over here, because this is an equation with 3 variables. Let's make that 1 variable. So we get 36 equals 2 times 8 plus b. 36 equals 2 times 8, which is 16 plus b. Subtract 16 from this side, each side, and we get b equals 20. And it's exactly what we have, right? Because that's our intercept. So that line crosses the y-axis where? At 20. And we already knew that, and that's just confirmation or a different way of finding the y-intercept. Okay? All right, so here's an equation. They actually gave you the equation. They're saying the equation is C equals 4W. So the only thing is, oops. Right, so instead of y equals 4x, right, they use C equals 4W. Big deal. It means the same exact thing. So here y is cost, and x, which is W, represents the weight. So is the equation of the line correct? That's what basically they're asking. Well, I know it's proportional because it goes through 0, so that's 1. Let me find k, our constant proportionality. There are 2 ways of finding k. A, you can find it right away. So again, I know these numbers are really bad, so this was supposed to be 1, 2, 3, 4. So at 1, can you find the unit rate? So when the weight is 1, when I buy 1 pound of whatever it is that I'm buying, how much is it going to cost me? It cost me $4. So I know the unit rate. So the unit rate, by the way, is $4 for 1 pound of whatever I'm buying. And if I know the unit rate, do I know K? Yeah, K is 4. And if I know K, can I get the equation? Yeah, y equals 4x. Which in this case is just written as C equals 4W. And it means the same thing. Okay, so that's one way you could have proven, okay, to see if that, what do you call it, if the equation of line was correct. 8. Find k in the equation of the line. Okay, again, now it's getting repetitive, but it's okay. Let's find k. Can we find a unit rate? Can I see? I can't see. This one's a nice one because I don't know what 1 matches with. I know where 1 is about here, but I don't like the word about. So when I can't precisely find the value or the unit rate, 1 and whatever, then unfortunately I'm going to have to use this to find the constant proportionality. So let's see if we can find an exact point. Well, they have 3 dots here, so basically I'm hoping they're telling us something. So again, this is 0, 4, and 8, so let me add some numbers. That's 2, that's 6, that's 10, 12, 14, so it's going by 2. So this point particularly is 5, 6. You can use this point here if you like, and that one, let me add the number 18, and that's 15 and 18. So it doesn't matter which number you use as long as it's on the line. So let's use 5 and 6. If I use 5 and 6, y is 6, k is 5, ta-da, done. That's my constant proportionality. And if I want to find my equation of the line, the equation of the line is y equals 6/5 x. Okay. Is that it? Yeah, that's it. 10. Explain if the graph has a proportional relationship or not, and explain what 0, 5 means in the context of the scenario. So here, and I think I talked to a couple of you today in the class about it, it is not proportional. Okay, that's by now proportional. I thought it's to everybody. Doesn't go through the origin, does not go through 0, 0, right? Does not cross the y-axis at 0, so it's not proportional. And in what situation can we have where, so here it's saying that if I play 2 games, I'll pay 15 bucks. If I play, what is this, 4 games, I'll pay $25. How is it that I played 0 games and I'm still playing, and the value here, by the way, is 5? How is it that I explain, how can you use a real life scenario to explain the fact that I went to this place, played 0 games, and I'm still paying $5? So a scenario, if you remember that bowling scenario, when you go bowling, I can play 0 games, before throwing a ball down the lane, and I already have paid a certain amount of money. Why? In most cases, when we go bowling, we rent shoes. So when we get there, we pay $3 for shoes, and before we even start playing, guess what? At 0 games that I bowled, I'm already paying, let's say, $3. So my bowling graph would be starting at 0. At 0 games, I already placed $3. At 1 game, it'd be the $3 plus whatever cost per game. So likewise here, what places are there that play games? Chuck E. Cheese doesn't charge money. Dave and Buster's, I don't remember. But those places, you just imagine that if they had an entrance fee, maybe a carnival. There you go, a carnival. Yeah, one of those big fairs. Okay, so to get in, you pay $5, and that's before you have done anything. Okay, so at 0 games, there's your, and that you can explain that $5 that you pay as your entrance fee. Okay, so that would be a good explanation. Okay. Is that it? No, there's more. There has to be more. All right, 2 more. Okay, that's not that bad. 11, find k, blah, 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 and all that stuff. All right. In order to find k, we can do it a really easy way. Find the unit rate, and I can find, here's the unit rate. It's exactly on that intersection. So let me write the unit rate first of all. It's miles over, what is this? Practices. How far must, okay, every time, okay, so I see. Every time she practices, so in one practice, she does how many miles? 2 miles. And that's the unit rate. And if I know the unit rate, guess what? I know what k is, and k is that number. And because this is proportional, the equation of the line is very simple. It's just y equals 2x. And here, on the test, I would say this identifies. So here's my unit rate. Here's the equation of the line. And there's k. All right. The last one, create a table, blah, 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 whatever that says. Okay, create a table. Okay, so before I do anything, I create a table and then graph it. Okay, so they give me the equation, so that's nice and easy. So let me create a table. So here's x. Right? I'm going to create a table, which means I want to create a few points so I can graph this relationship. So I know here's my equation, y equals 2.5x. So here's my y, and here's my ordered pair. So let's just, and here is 2.5x. Right? We're gonna substitute. So let's pick a few values. Pick a value 0, 1, 2, 3. That's enough. So when x equals 0, well, we're gonna multiply 2.5 times 0, and that's 0. So my first order pair is 0, 0. So right here. When x equals 1, well, we're going to multiply 2.5 times 1, and we get 2.5. So when x equals 1, y is 2.5. When x equals 2, well, 2.5 times 2 is 5, so we get 2 and 5. When x equals 3 is 2.5 times 3, which is 7.5, and then it's 3 and 7.5. We have 0, 0. So let me put some points here. So that's 0, 1, 2, 3, 4, 5. And here we're going to go by 2.5. Okay, so this is 2.5. This is 5. This is 7.5. This is 10. And this is my, and again, please don't forget this, my y, and this is my x. So from my table that I just created, I mean, we only need 2 points to make a line, right? But I put a few extra. 1 and 2.5, 2 and 5, 0, 0, 3 and 7.5. I mean, and you can guess what the rest are, right? And I'm going to create a line, stretch it out, nice and long, all the way out. Okay, and give it a name. Here's my unit rate. I can identify. I can even put with this. Here's my unit rate. I don't know if it asked for it, but k is 2.5. So notice that every time, yeah, right, 1, it's times 2.5, times 2.5, times 2.5. So that's my constant proportionality. Okay. Again, like I said, most of you have this done, so just use it to check. All right.